Hello, everybody, and my name is Sonali, and I'm here to talk about problems in multiple comparisons, and that's our question number 9 in homework 3. So let's talk about it. Basically, what is multiple t-test? So when we compare the several groups uh, in a patients with the help of two sample unpaired t-test, it's called as a multiple t-test. So what we do, we take the possible pairwise combinations in data and we compare the resulting p-values, etc. But it says that it is not a appropriate approach because it commonly seen in medical literature that it causes several statistical errors. So let's see how it actually causes it. So this is the hypothetical study. I have coined it for you. It says there are four groups of antibiotics, and there are 100 patients who are going to receive these four different types of antibiotics. We're going to assess the efficacy of each of the antibiotics in preventing the post-operative wound infection. We're going to use the two sample unpaired t-test in the 6 pairwise comparisons, like for example drug A versus drug B versus drug C, drug B versus D, like that. What is the problem with this approach? See, however small, there is always a chance that we're going to make a type 1 error. That is, we will erroneously reject the null hypothesis when in reality it is true, when there is no difference in the groups. So in single two sample t-test with the significance level of 0.05, we have chances of making type 1 error, that is only 5%. This is known as per comparison error rate. Okay. However, if we use the same two sample t-test to evaluate the 4 different groups instead of 2, that is more than 2 groups, with 6 possible comparisons, the likelihood of making type 1 error would be 30%, that is 0.05 into 6. So that is called as a per experiment error rate. So what we are doing, instead of having 95% confidence that our conclusions are correct, now we have only 70% of confidence interval that we are correct. And that's the reason we are more likely to commit the type 1 error. That is the biggest problem with multiple comparison. The one more is, if we test the multiple independent null hypothesis, the probability, that's the p-value, might become statistically significant by chance alone is increases. So all I mean is, when we do the 10 different null hypothesis, when we test 10 different independent null hypothesis, the p-value at the of obtaining the statistical significant result at the alpha level of 0.05 is 40%. But for 50 null hypotheses, it would be 92%. For 100, it would be 99%. So we need to interpret and calculate the p-value very cautiously. So what are the options we have to deal while dealing with multiple comparisons? We can go for this Bonifaris adjustment. So what is it? So it basically focuses on, are all the groups different from each other and how it's going to benefit to us. Let's see. So basically we want to determine that all the 4 groups were different from each other. It is all 4 antibiotics with the 95% of confidence level and statistical significant at 0.05. So with this Bonifaris adjustment, what we're going to do is, we're going to divide our desired per experiment error by number of comparison, and that's what I have done over here. 0.05 divided by 6. So we get the value of 0.0083. So now we can conclude, if all the 6 tests in if of their p-value is less than 0.0083, we can conclude that all those 4 different groups are statistically different from each other with the 95% of confidence. So here I have calculated actually with the t-test, two t sample test, and we can see that there are we have different values of p values, and we don't want that. So that is a basic problem by using the t sample t test. But now there is a one more disadvantage with the Bonifaris adjustment, and that is, although it it only estimates the true per experiment error rate. So although it reduces likelihood of making type 1 error, it definitely increases the chances of committing type 2 error, because it loses the statistical power. So what other options we have? So we have analysis of variance, that's ANOVA. We have learnt in class details about this. So basically we calculate the F statistic, which focuses on variation among the sample means, that is between the groups variance, and variation among the individuals, that is within the group variance. So it definitely helpful in multiple comparison, dealing with multiple comparisons, because it reduces the chances of type 1. So it concludes very nicely without making the type 1 error. And one more is like meta-analysis. It is also very helpful while dealing with multiple comparisons, but I'm not talking in detail about it because it's not in our syllabus. So this is it. So I hope you guys have enjoyed this video and you have liked it. Thank you.